Okay, welcome to another video from successtutoring.co.uk. Today what we're going to be doing is looking at grade A and grade A star surface area and volume questions. Questions that will require you in your answer to find an expression for r in terms of x. That's question number 1. Question 2 will require you to equate the volume of two different shapes, similar to question number 3. Question number 4, you've got to give your answer for the surface area of a hemisphere in terms of pi. And question number 5 is a two-part question involving surface area and volume. I've put a link to the lesson if you want to take part in it. You just download the blank slides and you can follow the lesson. I've also put the times for each question as well, if you just want to forward to the one you want to have a go at. Okay, so let's try this question. The diagram shows a solid wax cylinder. They're telling us here the cylinder has a base radius of 2x and a height of 9x, which you can see in the diagram. The cylinder is melted down into a sphere of radius r, so they've not given us a value for r. They're telling us to find an expression for r in terms of x. So how do we do this? These types of questions are asking you to equate the volume of two shapes. That's all they're asking you to do. Okay, you have to use a bit of algebra to work it out as well. So we're going to go ahead and try and figure this out. The first bit of information we need to memorize, okay, is the volume of a cylinder. So I'm going to put VC is equal to pi r squared h. This means pi times r squared times height. Okay, I'll write it here as well. This is what it means: pi times r squared times h. Okay, they've also told us that this shape was melted down into a sphere, so we need to know the volume of a sphere off by heart as well. So I'm going to put volume S there is equal to 4/3 pi r cubed. Okay, similar to here, it means 4/3 multiplied by pi multiplied by r to the power of 3, or r cubed. We need to understand those formulas first and foremost. What they are actually saying to us is find an expression for r in terms of x. Now you might be wondering, what on earth are they talking about? Basically, this is how I teach my students. Just a quick strategy to remember. I'm going to write here r in terms of x. Now this part here, in terms of, watch what I do. Draw a little arrow and scroll down just a little. I'm going to put an equals sign here, and I'm going to put an x there, and I'm going to put an r, because I know my answer has to look like r is equal to some value of x. It could be, I don't know, r is equal to 2x, or r is equal to 10x. Could be something like that. We're looking for an answer like that. R in terms of x, where r is equal to x. Okay, so let's go ahead now. What we need to do is equate these two formulas and end up where we have r is equal to something. Let's do that now. I'm just going to scroll down. I'm going to write out the volume of a cylinder, so I'm going to put VC is equal to VS. Okay, so all I'm going to do is just write underneath. So I'm going to put pi r squared h is equal to 4 over 3 pi r cubed. But they gave us some information, didn't they, about the dimensions of the cylinder. They told us that the cylinder here, the radius of the cylinder is 2x. So I'm going to rewrite that. And they told us the height is 9x. So I'm going to rewrite that as well underneath. So I'm going to put in brackets here, I'm going to put 2x squared, remember, multiplied. Just showing you we've got 9x. Okay, all I've done is just replace the dimensions that they gave me. I'm going to put equals, and I'm just going to rewrite the formula for the volume of a sphere here, r cubed. Now let's expand this out. Now you should already know that 2x squared is going to be 4x squared. Okay, so we're going to end up with pi 4x squared times 9x. I'm just working on this side first. Okay, is equal to 4 over 3 pi r cubed. We can go ahead and multiply the 4x by the 9x. That's going to give me 36x to the power of 3. So I'm going to write it as 36x to the power of 3 pi is equal to 4 over 3 pi r cubed. Now here's where you need to pay attention. We're going to make r the subject of this, okay, because we need an answer that says r is equal to x values or x terms. Okay, so let's do it. So I'll write it up here. What I'm going to do is equate this now. I'm going to do 36x to the power of 3 pi, and I'm going to do 4 over 3 pi r cubed. What I'm going to do is get rid of the fraction, okay, here. So I'm going to multiply both sides by 3. That's going to give me 108 x to the power of 3 pi, and all you're going to end up here is 4 pi r cubed. Listen very carefully now. I'll use a different color. I'm going to cancel out the pi because both sides can cancel. I'm going to divide both sides by 4. Okay, so that 4 is going to disappear. So underneath I'm going to write it now. You're going to get 27 x to the power of 3 is equal to r cubed. Do you see what's just happened now? We have a number 27. We can find the cube root of it because now we've got an r on its own, but it's to the power of 3. So I have to find the cube root of both sides. So I'm just going to rearrange that now, just writing it so it's r cubed is equal to 27x to the power of 3. I'm going to take the cube root of both sides. R to the power of 3 is equal to 27x to the power of 3. That's just going to leave me with r is equal to 3x. Okay, so let's try this question now. This is very similar to the previous question that we've just done. We've got a cylinder and we've got a cone. It says here, a cylinder has a base radius x centimeters, right, and a height 2x centimeters. A cone has a base radius x centimeters and a height h centimeters. the volume of the cylinder and the volume of the cone are equal. So we're going to have to equate the two volumes again. That's all we're doing. Here's the key part, how they want the answer to be displayed. Find h in terms of x. Remember what we said? We're looking for, therefore, h is equal, let's make that a bit longer, h is equal to some value of x. So what we need to do, let's first of all just go straight in and equate our volumes. So the volume of a cylinder, I'm going to put Cy, is equal to volume of a cone. Okay, let me just scroll down just a little bit here. So it's nothing. Now let's write the volume of a cylinder out. We know it's pi r squared times h. The volume of a cone is 1/3 pi r squared h. Now they've given us some dimensions, so we need to plug those dimensions into this formula. So let's focus just at the moment on the height and the radius of the cylinder. So the height of the cylinder is 2x and the radius is going to be x. So we're going to put x squared, I'm going to put brackets again, 2x close brackets is equal to, we've got the height h of the cone, and the base radius of the cone is x again. So what we've got now, we're going to do 1/3 pi, open brackets, we're going to put our radius in, which is x, we're going to square it just like what they've got here, and we're going to multiply that by the height, which is h. Okay, so just scroll down a bit now. You should already know how to expand this out. So what we've got here, we've got pi x squared 2x is equal to 1/3 pi x squared h. Multiplying these two terms together, that's going to give me pi 2x to the power of 3 is equal to 1/3 pi x h. Notice here we've only got one letter h here. Okay, we're going back to what we said earlier. H is equal to some value of x. I'm going to use a different color, and what I'm going to do, I'm going to start to cancel what looks like could be cancelled. I can get rid of the pi's. Get rid of the pi's. Anyway, let's get rid of those. Okay, the x squared, I can get rid of that too, and I'm going to have an x cubed here. So I'm going to get rid of x squared by dividing. I'm going to get rid of the power here. You should know how to do this by now. Okay, so now we've got, I'm going to rewrite it underneath in a different color. You should only have 2x is equal to 1/3 h. Let's rewrite that now. I'll do it up here. We've got 1/3 h is equal to 2x. What would I need to do to get rid of the 1/3? I need to multiply both sides by 3. So that's just going to leave me with h is equal to 6x. And that is your final answer. Okay, let's have a go at this question now. They're telling us here, the diagram shows a solid cone and a solid hemisphere. The cone has a base radius, also they've given us some new dimensions of x centimeters and a height of h centimeters. Can you see that here? The surface, sorry, I missed the line. The hemisphere has a base radius of x centimeters. These are the terms that you're going to use to substitute into your formulas, just like in the previous question. What's different about this now is we're looking at surface area, and they've told us the surface area of the cone is equal to the surface area of the hemisphere, and they want us to find an expression for h in terms of x. So you should already know, just like in the previous question, you can have h is equal to some value of x. Could be 2x, but we're going to work it out, for instance. Watch now. You should already know the formula for the surface area of a cone, and they've told us it's equal to the surface area of a hemisphere. So I'll just put hem, yeah? There you go. So pi RL is equal to 2 pi r squared. Okay? We've got dimensions, let's plug those in. Pi, let's look at the surface area of the cone. We should know the base radius here is x, so r is x. We took that value from here. The same again, the base radius is x, so 2 replacing r squared with x squared. Now we can go ahead and simply just cancel what can be cancelled. Pi can be cancelled. This x can be cancelled with this squared term. And now what you're left with is L is equal to 2x. But I thought we were supposed to have an answer that looked like that. So how can we end up with L? If you notice here, L is the slanted height of the cone. But we know that L is equal to 2x. So I can replace this value here. I can replace the L with 2x. Let's go ahead and try and draw out what appears to be a triangle. If you notice here, you've got a height h, we've got L, and we've got an x here. I'm going to redraw the triangle just here, but instead of, we know L is 2x, so instead of putting L, I'm going to write 2x. We've got a height and we've got x. Now this fits what we're trying to find. H is equal to 2x, or h is equal to x, or whatever value of x. Okay? But it looks a bit odd because we don't want this triangle. You need to use Pythagoras to work it out. Okay, so let's try and do that now. You should already know h squared, which is here, is equal to the longest side, which is going to be 2x. I'm going to square that, take away the shortest side, which is just x squared. Let's go ahead and do that now. That's going to give me 4x squared minus x squared. These two values can simplify. That's going to give me 3x squared. Okay. Now we just want to have h is equal to something. At the moment we've got h squared. So we're going to have to square root both sides. So let's do that now. 3x squared. And that's going to leave me with an answer of h is equal to the square root of 3x. It's only x that's not in the square root, because previously, if you noticed, I draw an arrow, we had x squared. When you square root x squared, it will give you x. So your final answer is h equals the square root of 3 multiplied by x. Right, let's have a look at this one. The diagram shows a solid hemisphere of radius 5 centimeters. Find the total surface area of the solid hemisphere. Give your answer in terms of pi. Now clearly, let's zoom in actually on this one. This is a bit clearer. There you go. Now the problem with these types of questions is this. Most students will only work out the curved surface area. But in this one, they're asking for the total surface area. Okay. So, first things first, we need to leave our answer in terms of pi. What is the formula for surface area of a hemisphere? So I'm going to put surface area of a hem, that's for short. I know that's equal to 2 pi r squared. Okay. Plus, we want the base as well. Pi r squared. Okay. What we're going to do is replace our radius of 5 centimeters. It's going to be 2 pi, I'm just going to put 5 squared plus pi 5 squared. Now clearly we know that's 25, so we're just going to get 2 pi 25 plus pi 25. It's going to give me 50 pi plus 25 pi. So that's just going to give me 75 pi when you add these two together. And that's your final answer. Well, let's have a look at this question now. It's a two-part question. The radius of a sphere is 3 centimeters, which you can see. The radius of the base of a cone is also 3 centimeters. The volume of the sphere is 3 times the volume of a cone. Okay, what do they mean? The volume of sphere is 3 times the volume of the cone. I'm just going to replace the word is with equals. Volume of sphere is equal to 3 times the volume of the cone. You need to know this. They want the curved surface area of the cone, so we're going to have to find what this is equal to. Okay, so it's a two-part question. We're going to equate the formulas for the volume, and then we're going to use that to find out what the surface area or the curved surface area of the cone is. And we need to give our answer as a multiple of pi. So it's going to look something like 2 pi or, I don't know, 30 pi. Okay, so let's begin. Let's start by writing out the formulas for the volume. We've got 4 over 3 pi r cubed is equal to, what did they say? 3 times. Yes, so we're going to do 3 multiplied by 1/3 pi r squared h. Let's plug in our values. The radii for each of these shapes is 3. So let's go ahead and do that. 4 over 3 pi. We already know r to the power of 3 is 27. So I'm just going to write 27 there. And then we've got this 3 times 1/3 pi. 3 squared will give me 9h. What I'm now going to do is factorize out the 4 out of this part here, because it will expose the 1/3. You should already know how to do this, making it easier to cancel down. Okay, and simplify. Scroll down slightly. Okay. Using a different colored pen, I can get rid of the pi there. I can get rid of the 1/3 and the 1/3. Okay, we know, therefore we've got 4 times 27 is equal to 3 times 9h Okay, that's going to give me 108 is equal to 9, 18, 27. H. Okay, what does this give me? If I divide both sides by 27, sorry, H is equal to 4. So we're going to use this value of H just like we did in the previous question, because we know H is going to be the height of the cone, which is 4 centimeters. The radius, we already know, they've told us, is 3 centimeters. And we need to find out what L is going to be, don't we? Because we need to plug L into here to solve the problem. You should know Pythagoras just like in the previous question. 4 squared plus 3 squared will give me 16 plus 9, which is 25. I'm going to take the square root of that, and that's going to give me 5. So L is equal to 5 centimeters. Okay, so I'm going to write it here, 5 centimeters. What do we know? We know L. We can now plug it into this formula here to find out the curved surface area. Let's do that. Pi, open brackets, R is 3. Close brackets, open brackets again, L is 5. Close brackets. That's going to give me 15 pi. Okay? 15 pi. Is it similar to what we were trying to find? Yes, it is, because we've got a whole number multiplied by pi. So therefore 15 pi is our final answer. Okay, that concludes part 1 of the A and A star surface area and volume questions. Feel free to like and share my videos. Also visit my website www.success-tutoring.co.uk. Stay tuned for part 2.